June 2005, Core 4 question 3 is a very strange question, not one you get anymore. Normally this would now say use the remainder theorem to do this. So let's do that. Use the remainder theorem to do this. The value we've got to try and find out is the value that makes that 0 is a half, and so we're doing f of a half if f of x is equal to this thing. And so we're doing f of a half. It's 2 lots of a half cubed minus a half squared plus 2 lots of a half minus 2. That all works out to be minus 1. And so the remainder, therefore, remainder equals minus 1. And that's how I would do it in normal papers. But actually, given that we've got to do the divide here anyway, for this question, you might as well just have done the divide, because setting up my divide grid here, I'm dividing by 2x take away 1. Well, I need a 2x cubed to start with, so I need an x squared here, because 2 times, it's not going to go in the grid, is it? The orientation's a bit off here. Gives me a minus 2x squared in here, and you can see, well, it gives me a minus x squared in here. And this minus x squared here is actually what I want, so I don't need anything in the middle here at all. There's nothing, there's no x's here in the middle at all. But I still need another 2 x's, and so in this box here I'm going to need another 2 x's. And clearly that's just 1 times this 2x here. 1 times minus 1 makes a minus 1 in here, and that's why minus 1 down to the minus 2 is a remainder of minus 1. So what does this big long divide give? Well, it does give, look here, we've got it here. It gives us x squared plus 1 minus 1 over 2x minus 1. That 1 is the one there, that 1 is the minus 1 there. So actually just doing divides quicker. I suppose there are other ways of doing it in that you could actually combine all of this together and say we've got x squared, lots of 2x take away 1, plus a, lots of 2x minus 1, plus b. That's the top line of that one there, and that has to equal the big long cubic as well. There's another way of doing it there. And now let x equal a half. That makes that 0, that makes that 0, makes b minus 1. Same maths as you did in the first part. And the other thing you could just do is say count the x's. Counting the x's here, we've got 2ax's here. Counted the x's here, we've got 2 of them. Loads of ways of doing it. The mark scheme for that does it in yet another way of splitting up the fraction there. Not something you get these days.